Now we're going to take a look at the power rule with negative exponents. So we'll start with something basic where we have in parentheses v to the sixth, outside of parentheses to the power of negative 6. So here we can see we have a power to a power. And we know from before that when we have that, we multiply the exponent. So one way of doing this is just saying, well, let's put that in blue, equals v to the 6 times negative 6. And that gives me v to the negative 36. We know we're going to write our answer with a positive exponent. So we can say this is over 1. And we'll take v to the negative 36 across the fraction bar. So our final answer will be 1 over v to the 36th power. All right, let's take a look at a second way of approaching this. So we could say, you know what? I'm going to think about v to the 6 as my base. And I know when I have a base to the negative exponent, I can begin with just taking the reciprocal. So I could think about this as being over 1 and taking this across the fraction bar. So that's going to give me 1 over, you don't change your base. Our base is v to the 6, but that negative 6 outside the parentheses goes to positive 6. So we can start by doing that. And now I want to simplify the denominator. So 1 in the numerator. In the denominator, I still have a power to a power, but the exponents are all positive. So I have v to the 6 times 6, and that's equal to our final answer, 1 over v to the 36th power. All right, let's try a product in parentheses to a power. So we have in parentheses 4w to the 6 x to the negative 3. Outside of parentheses to the negative 3 power. So again, we have a power or multiple powers to a power. So from before, we can look at this as like distributing over multiplication. So we have this negative 3 exponent that goes there, there. Now remember your 4, the 4, you can think about that as having like an exponent of 1. All right, so that would give us 4 to the first power being raised to the negative 3, and w to the 6th power being raised to the negative 3, and x to the negative 3 being raised to the negative 3. All right, power to a power, you multiply the exponents. So we would have 4 to the 1 times negative 3, which gives us 4 to the negative 3. And then we have w to the 6 times negative 3, so w to the negative 18. And then x to the negative 3 times negative 3, x to the 9th. We want to write our answer without negative exponents. So I'm going to put this over 1. And we'll take 4 to the negative 3 and w to the negative 18 across the fraction bar. So that's going to give us x to the 9th in the numerator over 4 cubed times w to the 18th in the denominator. And we'll evaluate the 4 cubed. Why not? So that gives us x to the 9th over 64 w to the 18th. All right, I want to try this again. So There's multiple ways you could start with this if you wanted to take a reciprocal, okay? Um, you could start inside of the parentheses, and you see inside of the parentheses, you have something with a negative exponent, x to the negative 3. So if you think about that, inside of the parentheses being like over 1, I'm going to extend that parentheses so we understand the over 1 is still in parentheses. And you could take x to the negative 3 across the fraction bar. So if I rewrite that, it would look like parentheses 4w to the 6 over x cubed outside of parentheses to the negative 3. All right, now we do have a negative exponent outside of parentheses, and we know from before that when that happens, if I take the reciprocal of what's inside of parentheses, that's our base, that will make that outside exponent positive. So what I'm saying here is that will equal x cubed over 4w to the 6th power, close parentheses, and now to the power of 3. Now that exponent's positive. All positive exponents. And now I'm going to cube my numerator and cube everything in my denominator. So it's like me saying I have x cubed and 4w to the 6th cubed. All right, so in the numerator, I have x to the 9th because we multiply the exponents 3 times 3. In the denominator, you're going to cube the 4 and cube w to the 6th. So we have 4 cubed and w to the 6th cubed, which gives us x to the 9th, 6 over 64 times w to the 18th power. Okay, you pick the method that you prefer. So I want you to take a look at the next two examples. We have in parentheses y to the 7th, close parentheses, to the negative 5. And then we also have parentheses 4b cubed c to the negative 6, close parentheses, to the negative 2 power. Pause the video, try those, and then we'll do them together. All right, let's take a look at the first one. So if you're just using the power rule straight up, it would be y to the 7 times negative 5, which gives you y to the negative 35. And then you want to take that across the fraction bar so that we have a positive exponent. So that gives us 1 over y to the 35th. All right, I'll try this the other way that I did it before so you can see it again. So I'm going to start with taking the reciprocal of y to the 7th. And now it's to the positive 5 power. The numerator is 1. And then I'm applying my power rule. So I have 1 over, then it's y to the 7 times 5, which gives me 1 over y to the 35th. All right. Second example, we're going to distribute that negative 2 across the multiplication. So to the 4, to the b cubed, to the c to the negative 6. Essentially, that gives us 4 to the negative 2. B cubed to the negative 2. C to the negative 6 to the negative 2. So you want to remember you want to remember to multiply these exponents to each of these factors, right? Remember, 4 is being taken to the first power. So that's 4 to the 1 times -2, 4 to the -2. B to the 3 times -2, B to the -6. C to the -6 times -2, so that's +12. And over 1, so we want to take 4 to the -2 and B to the -6 across the fraction bar. That's going to give us, in the numerator, C to the 12, over in the denominator 4 squared, B to the 6. Evaluate the 4 squared, so C to the 12, 4 times 4 is 16, over 16, B to the 6th power. Okay, if you start with taking reciprocals, there's multiple ways you can do it. I'm going to do everything. So first, if I start inside of parentheses, that's going to give me a fraction 4b cubed over c to the 6th. Outside of parentheses, we still have a -2. Now I'm going to take a reciprocal of everything inside of the parentheses. So we have c to the 6th over 4b cubed, and that's squared. So that means I need to do c to the 6th has to be squared, right? 4 squared and b cubed is squared. So we have c to the 12th over 16, b to the 6th. Same answer as we got before.